A non-repeating permutation means that in the arrangement, there will be no repetition of the letters or numbers or symbols that are included. So for example 1, the password for a cell phone app is a 5-digit non-repeating code. How many possible arrangements are there? So if we are limited to numbers, so for example, on the first slot, we can only use from 0 to 9, so that's 10 possible choices from 0 to 9. It can be 0 or 1 or 2 or 3 up to 9. Now, for the next slot, we can only use, if you use a first number, for example, 3 on the first slot, we can only use 9 numbers now because you have already used 3 and you cannot repeat 3 for the second slot. So for the second slot, it's only 9. Now, after the second slot, there are 2 numbers already used. So for the third slot, there's only 8 possible numbers that you can use. And then in here is 7 and then 6. So if you multiply all of this, the total possible arrangement is 30,240. Now, we would like to have a formula for non-repeating permutation, and I would like to introduce to you a new term, factorial. So the factorial of a number is the product of that number and all the positive integers below it. For example, the factorial of 4 or 4 factorial, the symbol is the exclamation point. 4 factorial will be 4 times 3 times 2 times 1. Now we would like to make a formula to make it easier for non-repeating permutation. For this example, the permutation is 10 times 9 times 8. So we'll use 10 factorial as the top the number of combination, but this would entail that this will be 10 times 9 times 8 times 7 times 6 times 5 times 4 up to 1. So we want to remove that. So in order to remove that, we would want to remove, we have to put 5. So to get 5, it will be the number of choices, 10, minus the number of slots, so 5 factorial. So this is now our formula. Now, to make it like easier to remember, we put the number of choices on the left, n, and then the number of slots needed is called r. So if we apply it to this formula, this becomes n factorial over n minus r factorial. So we now have a formula for a non-repeating permutation, where r is the number of slots available, and n is the number of choices. Now we can use this formula for the second example. How many possible combinations of 3 horses winning first, second, and third place from a group of 7 horses? So we have 7 horses, A, B, C, D, E, F, and G. So we have first, second, and third. Now, it is possible that A, B, and C can win first, second, and third, but it could also be B, A, and C. is another combination. This time B wins first place, A second place, and C. Or it could be D, E, and F. But it could also be F, E, D winning first place, second place, and third place consecutively. Now, to apply, we just apply the formula that we have discussed. So, NPR, so the N is the number of choices. The number of choices, we have 7 choices of horses, so we put it in here. Now the number of slots, we have 3 slots. So there's 3 slots. So we apply the formula. That will become 7 factorial over 7 minus 3 factorial. We now have 7 factorial over 4 factorial. If we expand that one, that becomes 7 times 6 times 5 times 4 times 3 times 2 times 1 divided by 4 factorial is 4 times 3 times 2 times 1. Now we can cancel the same number, so this is cancelled, this is cancelled, this is cancelled, this is also cancelled. What we have left is 7 times 6 times 5, that's it. So that is 5 times 6 is 30 times 7 is 210.